Okay, so what we're going to be doing today is using differentiation, a form of calculus, to determine the nature of some turning points for this cubic graph. Y equals x cubed minus 6x squared plus 16. From that, we are then going to be able to draw a sketch of the function. So the first thing we need to do is we need to find the turning points. Now, a turning point on a graph looks something like this. It's right there. And it's at that point where the gradient of the graph is 0, i.e. dy by dx equals 0. Now dy by dx, if I differentiate this, don't forget I just bring the power down. So I bring the power down here, I get 3. And then I take 1 off the power, so I get 3x squared. Same again here, I get minus 12x, and then the constant disappears. The gradient of the constant, which would be a straight line, that equals 0. Now the gradient equals 0, the gradient function, at the turning points. This now gives me a function, or an equation, sorry, that I can solve, in this case a quadratic. What I'm going to do is I'm going to factorize. I have a 3x squared and a 12x, so what I can take out of brackets is 3x. And that will leave me with x minus 4. Therefore, the x coordinates of the turning point, i.e. where the graph isn't going up or down, is x equals 0 and x equals 4. Now, to find the y values, we just put it in here. When x is 0, 0, 0, we get 16. And when x is 4, just use your calculator because it's probably easiest. 4 squared plus 16, you get minus 16. So these are the coordinates of the turning points. I'm just going to write them up here so I can rub everything out. X equals 0, y equals 16, x equals 4, y equals minus 16. Now I can either use the first or the second differential test to determine the nature of these turning points. For this one, the first one, I'm going to use the first differential test. For the second one, I'll use the second differential test. If the question in the exam says use just one of the tests for both of them, you have to just do what the question says. Okay? Now, for the first differential test, so number 1, we're going to use the first differential test. The first differential test. What I need to do is I need to know dy by dx. So dy by dx, which we just said, was 3x squared minus 12x. What I'm going to do is I'm going to go a little bit either side of the turning point. The turning point was x equals 0, so I'm going to calculate x equals minus 0.01 and x equals 0.01. I'm going to put that in the calculator. So I'm going to do minus 0.01 and I'm going to substitute it into dy by dx for both of them. So for minus 0.01, I do 3 times x squared and then minus 12 times x. I get a positive number, 0.1203. And then for 0.01, I get a negative answer, minus 0.1197. So what that means is that a little bit to the left of the turning point, the gradient is positive, so it's going this way. A little bit to the right of the graph, it's negative, so it's going back down again. So let's just say that again. A little bit to the left, if the turning point's here at 0, is coming up, because that's a little bit to the left. And then a little bit to the right, it's going back down again. Therefore, the graph looks like that. And it is therefore a maximum at x equals 0. A maximum at x equals 0. That's the first differential test. You go a little bit to the left, a little bit to the right, you see what the gradient does, and then you determine if it's a maximum or a minimum, like that. Second differential test is quite honestly a lot easier. Find the second differential, i.e. differentiate this again. We call it d squared y by dx squared. Differentiate that, you get 6x, and you get minus 12. Now what I'm going to do is I'm going to substitute in the value itself. So the value is at x equals 4. So at x equals 4, I put it in here, I get 24, take away 12, which is 12. Now if the second differential is larger than 0, it's a minimum. Okay? This is larger than 0, which means it is a minimum at x equals 4. i.e. the graph goes down, it gets to x equals 4, stops, and then goes back up again. If d squared y by dx squared, the second differential, were smaller than 0, it would be a maximum. So what we know is that this is a max, and this is a minimum. Okay? That will allow me to sketch the graph. It has to be a sketch, it's not exactly accurate. So at x equals 0, y is 16. We'll put that there at 16. That is a local maximum, which means it comes like that. At x equals 4, which is going to be here, y is minus 16, so that's going to be down here. And that's at minus 16, that is at 16. And that's the minimum, so the graph comes up, comes back down, and then goes back up again. The graph looks something like that, where if that's the minimum, sorry, that there is 4. Again, it's a sketch, it doesn't matter. What does matter is that we have the y-intercepts and the coordinates of the two turning points on the graph. Okay? And that would be how you would use differentiation to determine the nature of the turning points and therefore sketch the graph.